Welcome to the DIY Honda Garage channel. The DTC P0562 indicates a situation where the charging system is operating at a low voltage. This occurs within the Honda Accord models manufactured between 2012 and 2017, particularly equipped with the K24W1 engine type. The primary component involved in this scenario is the alternator, which is responsible for generating electrical power while the engine runs. It receives commands from the Powertrain Control Module, PCM, through the local interconnect network, LIN line. The PCM aims to maintain the alternator output voltage between 12.5 to 14.5 volts. If the voltage detected at the FI main RLY out terminal drops to 11.0 volts or lower for an extended period, specifically 60 seconds, the PCM logs DTC P0562 to indicate a malfunction. To prevent future occurrences of DTC P0562, regular maintenance plays a vital role. Schedule consistent checks of the battery to ensure that it remains in optimal condition and readily holds a charge. Additionally, inspect the alternator drive belts for wear and tear, since a loose or damaged belt can lead to inadequate alternator function. Service all electrical connections by cleaning and applying corrosion inhibitors to terminals, further ensuring strong connectivity throughout the charging system. By adopting these preventive measures, you can significantly reduce unforeseen issues and extend the life of your vehicle's electrical system. In summary, understanding DTC P0562 and its implications regarding the vehicle's electrical system is crucial for optimal performance. The primary troubleshooting points encompass battery checks, alternator testing, wiring inspection, and PCM evaluation. Each step serves a purpose to identify the root cause of the low voltage issue. Additionally, proactive vehicle maintenance practices are equally important to prevent such faults in the future. By regularly monitoring and servicing the electrical components, you can enhance reliability while minimizing unexpected breakdowns. Furthermore, understanding the interconnected nature of these subsystems reinforces the importance of a comprehensive approach to vehicle diagnostics. The components primarily affected by DTC P0562 include the alternator, the Powertrain Control Module, PCM, and the electrical wiring associated with these units. The alternator generates electricity from mechanical energy provided by the engine and is located typically at the front of the engine bay. The PCM is an electronic brain located near the engine, responsible for regulating crucial engine functions and the alternator output. The specific role of the alternator in this context is to convert mechanical energy into electrical energy, while receiving voltage command inputs from the PCM through the LIN line. If there's a discrepancy in the expected voltage due to several factors like open circuits or internal faults, the PCM will recognize this issue, resulting in the DTC being logged. Several potential causes can lead to DTC P0562. First, alternator failure could result from an open field coil or stator coil, or a malfunctioning voltage regulator, preventing it from generating sufficient voltage. Another reason may involve the alternator stopping due to overheating, which could temporarily impair its functionality. Furthermore, disconnections at the alternator side plus B terminal or the underhood fuse/relay box plus B terminal can disrupt power flow, leading to low voltage detection. Lastly, there could be an internal circuit failure within the PCM itself, which can cause it to misinterpret voltage levels, incorrectly triggering the DTC. The common symptoms associated with DTC P0562 may include a battery warning light appearing on the dashboard, indicating charging issues. Additionally, you may experience various electrical system malfunctions, as insufficient voltage can impair various vehicle electronics. Such issues might manifest as dimming headlights, malfunctioning infotainment systems, or non-responsive electrical accessories. In some cases, a significantly low voltage could cause the engine to stall or fail to start entirely, resulting in potential safety hazards and driving inconvenience. Thus, monitoring these symptoms closely is vital for timely troubleshooting and resolution. The first step in troubleshooting DTC P0562 involves a thorough inspection of the battery's condition. Assess if the battery terminals show any signs of corrosion or loose connections, which can impede proper electrical connectivity. Next, it's advisable to conduct a load test on the battery to verify its capacity to deliver voltage under a simulated load. A fully functional battery should maintain above 12.4 volts during the testing phase. If the battery voltage is low, replacing it may be necessary. Additionally, ensure that both the positive and negative cables are secure and free of damage to facilitate effective power transmission. Following the battery check, the next step calls for testing the alternator's output using a multimeter. The multimeter should display the voltage generated by the alternator, which ideally should range between 12.5 to 14.5 volts when the engine is idling. If the alternator output dips below this range, further inspection is warranted. Specifically, examine the voltage regulator, which helps in maintaining the desired voltage output. A malfunctioning voltage regulator may cause erratic voltage levels, therefore potentially triggering DTC P0562. Consistent low output readings would indicate a failing alternator requiring replacement or repair. In this step, focus is directed toward inspecting the wiring connections linked to the alternator and PCM. Check the local interconnect network (LIN) line for any signs of shorts or open circuits, as this could interfere with communication between the alternator and PCM. Visually assess the wiring harnesses to identify breaks, fraying, or other damages. A damaged wire may cause inconsistent voltage readings, directly impacting system performance. Pay close attention to the +B terminal connections at both the alternator and underhood fuse relay box, ensuring tight and secure engagements to avoid unintended disruptions. The final troubleshooting step involves evaluating the PCM's functionality. Begin by running diagnostic tests using a certified scan tool that can access the PCM's data and fault codes. This process will help identify if the PCM is reporting errors or anomalies in its operation. Additionally, ensure that the PCM has the latest software updates, as older versions may contain bugs leading to incorrect diagnostics. If diagnostics indicate the PCM's failure, further investigation or replacement may be required to resolve DTC P0562 effectively. Confirming the PCM's operational integrity is crucial to eliminate it as a potential contributing factor in the low voltage issue. After completing necessary repairs or replacements, it is essential to clear the DTCs from the PCM. Use a diagnostic scan tool to perform this action, and then take the vehicle for a test drive to ensure that the system operates correctly under real-world conditions. During this process, monitor voltage readings using a multimeter to confirm that the alternator is now effectively maintaining the voltage within the specified range of 12.5 to 14.5 volts. Additionally, ensure that all warning lights on the dashboard have cleared and that no new codes have appeared in the PCM. This thorough verification will help ensure that the issue related to DTC P0562 has been addressed satisfactorily. Please like and subscribe to the channel. See you next time.